Hi, welcome to this Programming for Cultural Heritage lecture. Today we're going to get into web scraping with Python. So web scraping is basically ability to process a structured HTML page into a data set. And so the first things that we have to think about when we're going to talk about web scraping is when you should web scrape and when you don't need to web scrape. And then we're going to kind of do some examples of doing traditional web scraping. And so I say traditional because things change very quickly with web development. And so a web page that's built today is very different from a web page built, 10 years ago even or 5 years ago. So some methods of approaching web scraping will be very successful and some others, and we'll talk a little bit about that. But the kind of underlying nature of all web scraping is to extract this data from an HTML document and turn it into your own data set. And so you'd only want to do this when there's like no other option, right? So you want this data that's on a public site, you want to do something with it for a project or something like that, and they don't have the data available in any other format, so you have no choice but to use a website to pull the data down. But you do need to know when you need to web scrape or when you would be forced to web scrape versus when you don't need to do it. So if you think about how the web works, web pages work, this is basically how most of us use the web page every day. So there's a server, right? And that server talks to a database usually, and the server then takes your request and turns it into an HTML document and sends it down the pipe to your browser, and your browser renders it and you interact with it. Sometimes there might be an API that is actually connected to that server as well. So if you were going to be using, if you had the choice between using their API versus using their HTML page, you of course would want to use their API, right? Because their API returns JSON, which is highly structured data. You can use it to, pull out the information that you'd much rather use that rather than doing something like messing around with their HTML page and their HTML documents. So there might be an API that could be used. So definitely check out to see if there's an API first. And there actually might be like an undocumented API. So you could actually maybe snoop around the web page and see if the web page is being powered by an API that's not necessarily public, but still returns JSON. And so, this non-public API is basically something that powers these pages being built in your web browser, but they're not necessarily publicized. So, there could be some feature you could use your internet browser's developer tools to look for API requests being made, and if you see something that looks promising, then you could then use that for your data source as opposed to having to parse the HTML. And of course, best case scenario is that there is already a dump file generated or an exported file generated out of the database, and you don't have to go through their server at all or go through their web page or API at all. So you want to always make sure to check if there is a dump file out there already or if there is an API available, and definitely pursue those options before you go down the scraping route. So as I've been saying, this should be kind of like the last resort thing. Only start web scraping something because it could be very in-depth process and time consuming if you know for sure that this data is not out there in another format that's easier to use. Of course, I would just, caution to be a little bit wary about legal concerns. If it's on a public site, you should be fine because, these lawsuits have shown, that these public things are available to be scraped through the public internet. Of course, we're just doing things for educational purposes. The bigger thing, if you're working with smaller institutions or websites, that you want to be polite when working with their site, right? You could potentially run 10 Python scripts at once and talk to their server as much as possible to scrape as much as you can, as quickly as you can. But that's kind of not very nice to do that to their server because it's going to put a lot more strain on their server than just a normal person would or a normal browser. So try not to make too many requests too quickly. Do things like caching data, and be polite when interacting with their servers. So the kind of high-level workflow that we're going to be following for web scraping is basically requesting the HTML page from the website, parse that HTML page into a Python data structure, and then do things with that data structure like extract data. that we're looking for, and then export that for later uses. This might be another JSON file that we export out, or it could be a CSV file, for example. So we're going to be using two libraries for this. One we've used before and one is brand new. So we're going to be using the request library to do the actual requests, making the request to the web server to return the HTML page. And then we're going to be using Beautiful Soup, which is a library designed specifically for parsing HTML and allowing you to query it. So you want to make sure to install these two libraries, pip3 install requests and install Beautiful Soup 4. And of course, check out the previous video for using pip if you have any problems doing that. So the web scraping workflow is using these two libraries is that we're going to use requests to ask for the text of the page, the HTML. It's going to send us back the HTML. We're going to parse it with Beautiful Soup. And then we're going to ask Beautiful Soup to look for specific features of that web page to pull out the pieces of data that we want to return. Once that data is returned, then we can, of course, do whatever we want with it, like save it out to a file, JSON, CSV, etc. So some cautionary things I would say when you get started web scraping is that make sure the HTML is actually there when using this type of web scraping. So when I say actually there, you can think about how a web page is formulated, right? The web server puts together an HTML document and throws it down the internet to the pipe to your browser. That's not necessarily how modern day web pages work anymore. A lot of web pages today, they will actually send a huge JSON package to your web browser, and that JSON file will build the website in real time in your browser, and then talk to the server when needed via JSON. So the way that we're interacting with these servers is that we're assuming the server is sending us fully formed HTML pages to our browser. And in that case, we'd be sending fully formed HTML pages to our script. So if that's not the case, then this approach of doing web scraping is not going to work. So you want to make sure that the browser, and checking out the web page, the HTML is actually there. And a good rule of thumb is that if you right-click on the page and view source and find the piece of data you're looking for, then you're pretty confident that the web page is going to be it's going to look like that to your web scraping script. So when you view source on the page, that's basically how your Python script is going to view the page, and that's going to determine if the data that you want is actually there, or is it doing this really fancy JavaScript thing where it's building the page in your browser and that data is not actually there in the HTML sent from the server. So there are other avenues of web scraping sites like that that are more about controlling basically a headless browser, so a browser that doesn't have a display, but it can still interact with it. So the browser is rendering the web page, and you interact with that headless browser to pull out pieces of data that you want. We're not going to talk about that today, but we're going to more go after this idea that the web browser is sending a fully formed page to your script. And so also we're going to be using the web browser to inspect the HTML to figure out how to define these patterns that will help us pull out the pieces of data that we want. So here's some links to some guides to get started with web scraping, in addition to what we're going to talk about today using Beautiful Soup. But let's jump into some examples here of scraping. So when I said in the beginning or a few minutes ago about is the data really there? So if you, for example, we're looking at the Frick's Museum collection of art, and you just do a search for everything. So this looks like a pretty good avenue into thinking about, say, my objective was I want to pull all the pieces of works of art from the Frick's collection so I can do some analysis about whatever, right? But the problem there is that I would need to know an address for all of the works of art, right? Assuming each work of art has a little landing page like this that has details about the works of art that I could pull web scrape from, I would still need to know all of those URLs to actually get to those individual pages, right? And so you might be tempted to say like, oh, well, this is a good page for that, right? The search page lists everything, and as I scroll down, I see more and more stuff that's being listed, right? And so you'd be tempted to be like, okay, well, if I just scrape this page, I could get a link to all the items in the Frick collection. But if you look at the page source, you would quickly realize that basically this is what the site is going to be sending you. So if you can find the piece of data you want in here, then you know it's going to be in your Python script. So if I search for this name, for example, I can find it there, right? But if I scroll down much further to something that's been kind of newly loaded into the browser with this kind of infinitely scroll thing, let's see if I can find one of these things here. 7 decorative panels mounted in a screen. All right, so this was the previous work here, or this is for like an artist listing. So if I search for that title of the artwork, right, it's not going to show up. So this data being loaded in real time is not actually in the web page, right? This is some JavaScript thing loading it as we scroll further and further. So this in fact would not be a good kind of source for our script. Another one would be like, this Milwaukee Museum of Art web page. If we go to the collection and we do a search on everything, we can see that this has a landing page, and there's 900 pages of this landing page. And then if I did if I did a search for this work's title in the view source, so I'm right clicking and saying view page source. And I did Control F and find. I can find that piece of text actually in the HTML. So I know that this is, this data is going to be there. If I request this with my Python script, it would be there. So this kind of gets us into this idea of like, well, how do we approach a web scraping project, right? So you obviously would have to have an objective that you wanted to accomplish using web scraping. And in our cases, we're going to look at a couple museum sites, and our objective would be pretty obvious. We want to get the metadata for all of those works of art in their collection or something like that, or in a specific subsection of their collection. So in that case, you need to know how to get access to these individual pages to pull out the data, or have some sort of like index to this data, right? So this search page is considered kind of like an index to all the data, right? Because it has basically everything in this collection listed out per page. So you could approach this in a couple different ways, right? So you could say, well, if I went through all of these pages and I pulled out the titles and stuff from each one of these pages, then I basically have a complete scrape of all of their data for their works of art. So you could kind of formulate a plan to say like, okay, well, I could set this result page to 50, and then if I went through each one of these pages, 1 through 197, and then on each one of these pages, pull out these pieces of data from each piece of work of art, and then I would basically have more or less a pretty good picture of all the collection that they have there online. And so, you would have to weigh your options, right? Because you could say like, well, there's some basic metadata here, but then when I actually click into the actual page itself, there's much more detailed metadata there. So you have to think about like, well, maybe there's some other ways I could do scraping the site, right? So you really kind of have to figure out how the site works and then break down what is a good approach. For example, like for this Frick site, if I started noticing when you scroll over each page, you get a little preview of the URL it's going to go to, and all of their works of art start with the same URL. They say collections.frick.org/objects and then a number, right? So this is number 2645. And there's some extra bits here that's kind of like additional information in the URL. So I'd be curious, like if I deleted that and just went to /objects/2645, would it still work, right? And it does still work. And so then you'd say, well, what if I change a number from 2645 to 2646? And so, okay, that didn't work. What if I change it to 44? Okay, that didn't work. So what if I change this to a random number like 100? Okay, that did work. What if I change it to 101? So it does work. So there's some sort of pattern to this numbering scheme, right? So you could theoretically say, well, what if I just requested pages 0 through some arbitrary number? And knowing that sometimes it would work, like it would return a metadata or a page about the work of art, and then other times it would just say artwork not found, right? That's not a valid ID. So you just have to be like, well, okay, well, do I start with 0? Okay, 0 works. Do I start with like -1? Would that make sense? That doesn't make sense, right? No, that doesn't work. All right, so start with 0 and then go up to what number? Like 4,000? Would 4,000 work? Does that doesn't, it's not found. Whoops, 5,000. Oops, 500, 5,000. Oh, 5,000 worked. So there could at least go up to 5,000. So you'd have to play around with this URL, right? And then you could also go back to the search page and see what's the highest number object number you could find and be like, well, roughly, well, if I go to 6,000, is that too high? Etc. Right? So it seems like around 5,000 is a pretty good number. And so you would kind of formulate this like natural language code in your head, right? Like, all right, scrape each page starting with 0 to 5,000, and whenever there's like a one not found, skip it and don't try to pull that data out of there. So we have two approaches here, right? One would be, okay, use a search page to find all the listings of items that we can. And then the other one is, okay, we kind of know how the site is laid out. So I'm just going to request a bunch of these pages 0 to 5,000 to say, and pull out the data there. So you have to really kind of put yourself into the shoes of how the website works and then kind of go from there and try to dissect what's the best approach. So let's try it first with the Frick collection site. And so our approach to this was we're going to use kind of like a loop to keep requesting the number of pages up until around 5,000 or so until we hopefully scrape everything. So we have to think about this approach, right? So we're going to start off with 0, and we know sometimes the request could fail and it would say this item was not found. So of course we won't want to pull out data for those failures because there's no data. But for the rest of them, we want to get access to this metadata here on the side here, right? There's these different pieces of data for the various metadata. So first thing we need to do is we'll make a Python script. We'll start off. So I made a directory on my desktop called webscrape, and I'm going to save a new file there. And I'm going to call it Frick Scrape. Okay, so the first thing we need to do when we are going to be using this workflow is we need to request pages from the internet. So we know how to do that already, and we know we need to import the request module. And now this is the new thing we know we're gonna use this library called Beautiful Soup to parse the HTML pages to pull out the data. And so we need to import that library. And importing this one is a little bit different because it has multiple things inside of the Beautiful Soup package or library. So we have to say from BS4 import Beautiful Soup. And so this is just, you read the documentation on the Beautiful Soup page to show you how to start using it, and it would tell you how to do that. All right, so now we have the requests and we have the Beautiful Soup page loaded. We need to start thinking about our approach again, right? So we want to basically loop 5,000 times and then change the URL to include the new number. Then we want to like request the HTML from that page, but we want to make sure that if it's not found, then skip it. And then we want to pull out the metadata for that item for each page. All right, so we kind of have an approach here. So the first thing we need to do is figure out how to loop 5,000 times. And we know we start off at 0 and we'll go up to 5,000. And that's kind of our range of numbers that we discovered playing around with the site. So the first thing we do is we can say, okay, well, actually, I know we've talked about this function before, but there's a function called range. And you say what number to start on and what number to go to. And it will do that it will produce an iterator or kind of like a list type thing that you can loop through that many times. And for each iteration, it will be one of the numbers in that range. So we could say for number, or we'll say for item number in this range, 1 to 5,000. Now let's just print item number to make sure this works. So I'm going to go over to my and Python 3 frick scrape. All right, so it goes up to 4,099, and it starts at 1. So that's right, starts at 1. Oh no, both of these things are wrong, right? We want to start at 0 and go to 5,000. So we'll start at 0 and go to, and we know 5,000 actually works, so let's go to 6,000 just to be safe. And let's try to run it again. So we see, oops, we see it starts at 5,999 and it goes to 0 to 5,099. All right, so yeah, we can just add that 1 to the end of it, so we'll go to 6,000 even. All right, so now we have the number. So the next thing we want to do is make the URL to the object itself. And so we know from the website that the format of the URL is collection.frick.org/object and then the number. So what we can do is make that our string here. So we'll make a URL inside the loop, and we'll make it a template string with the F. And so then we have this template string, we'll call it URL, not URK. And then we can just slot in our item number for the 5,000 that we have hard-coded. Right, so now for each iteration, the URL will change, and we'll have a different URL for each loop. So let's see if it works. Yep, looks pretty good, right? Let's go to one of these, make sure they work. Great. All right, so next step is to actually request the contents of the page. And so we've done this before using requests, and we'll say r equals requests dot get, right? And we're going to get the URL we just built. And then here's the trick, right? We want to check to see if the URL works or not. And so we talked about how the internet works before, but if you go to one of these pages where it does work and you look at the network tab and you inspect the request, you'd see that it returns a status 200 here. So I loaded the network, the developer tools like the network tab, and so it returned 200, right? So we know that, say, 6,000 doesn't work. So if we go to 6,000, we can see that it returned status code 404, not found. So we could actually check that, right? We could say, okay, if it returned 200, okay, then continue with the scraping. If it returned 404, skip it, right? So we know that we can test the status code because we've done this before, and we can say if r.status underscore code equals 200, then we know that we're in the right place. And so we could test this because we could say we know like 5,000 works, but then maybe 5,001 doesn't work. So we could tell it to start off at 5,000 or 499 and go into 6,001, and then we'll just print the if it's okay or not. And we'll print the URL. So it's going to do a bunch of requests really quickly, and we should see ones that are correct and not 404s. All right, so immediately we got some sort of errors around. It says their certificate verify failed, and it's talking about this SSL error and stuff like that. So I think honestly there's something wrong with the certificate that they're using to encrypt their website might be a little bit weird because this works for other websites with HTTPS. So we know it's an SSL problem. So what we could do is just turn off SSL for our script. It's not really a big deal to have it enabled for this script because it's just it's just talking to these items and pulling back data. So we have this HTTPS here, and that's making it secure with the SSL. So if we just take out the S, then it will just request the non-encrypted version, and that might work. Let's try that one. Yeah, all right, so that worked. So there might be something funky going on with their certificates or something like that that's it's not being trusted, but we don't have to use the secure socket. We can just use the regular HTTP and not HTTPS, and it still works for us. All right, so we were checking to see if we could check for the status code to see if it returned a 404 or 200, and we could see that it went through all of these and they didn't work. But then it got to 5028, and that one did work. So we could go verify that and go to that URL and see that, yes, that is there. That is a plate that exists in their collection. All right, so we now know how we can go from like 0 to 6,000 and skip the ones that are not really there or don't exist. And we just put the code that there are, one that does exist here, and we could work on pulling out the metadata for that. So I'm gonna put this back to 1 or 0 to start off the beginning. And what I'm gonna do is put a break command at the end of this here. So it's only gonna do the very first one, and it's gonna hit this line and then break the script and stop the loop. So it's gonna break the loop and stop the script, so it won't continue. So it would only do the very first one when we ran it. And I'm just doing this so it doesn't, we're going to spend some time working on the pulling out the metadata. We don't need to do it for all of them yet. We just want to make sure it works for the first one. All right. So we're able to pull out that, we're able to at least load that data from the site and return the HTML. So the first thing that we need to do when we're doing web scraping is identify our kind of approach to pulling out the data, the metadata that we want to use. And so you can see like there's a title here, there is a URL to the creator, there's a date, there's a medium, dimensions, credit line, accession number. This is like tag or something. So the way that this works is that you have to inspect the HTML and say, okay, I need to figure out a way to pull out these various fields. And you can see that there is each one of these pieces of data is in a div element. And each one of those divs has a children underneath of it and the text. Like, so here's the title. It's in data field, title field, and those are the two classes. And so again, classes are like just ways to apply style to an element, CSS style. And so these have two classes. And then this one has two classes too for the person. And then there's a link inside of there with the person's name. There's actually two pieces to it. There's the name, and then there's this like nationality. So you'd have to kind of think about, well, how would I get to this one piece of the HTML element to pull it out? And so you can see that all of this is stored underneath of the item details inner, but then more importantly, each one of these detail fields has the class detail field, and then it has a little additional class about the title or whatever. So we can actually use that to direct Beautiful Soup to find just the piece of HTML that we want to yank out there. So we could make that our approach, right? So to get the title, at least, we're going to look for a div that has the class data field and title field together. So let's go back to our script and we'll start working on that. So we have our HTML, and it's actually stored in this request response as text, right? That's our actual HTML is stored in there. And so what we can do is we can pass this over to Beautiful Soup, and it will parse it for us and turn it into a queryable kind of structure. And so what we can do is say, okay, our soup is going to be equal to beautiful soup, and to it we're going to pass our HTML, the text of the request. So that's going to parse it and it's going to return back a beautiful soup object. That's basically allows you to query it. And so by query, it means I can say, I want you to return all of the divs or all the specific things that you can find, right? So we can do this. So we could say all divs equals soup.find all, and then what do you want to look for? We want to look for the divs. And so if we did a loop, we could say for div in all divs, and let's print out the div. Let's print out a little line after each one. So if you did this, it would find all the divs on the page, hopefully, and then print them out one by one. So here's a div, here's another div, and somewhere in here would be the specific div that we're looking for, which is the title information. And so this, we need to specify, be more specific about what type of div we're looking for, because there's all sorts of divs on the page. So we know that the div that we're looking for specifically has the class data field and title field. And so what you can do is you can tell Beautiful Soup to only look for divs that have that by passing a second parameter. And the second parameter is going to be a dictionary of key value pairs of things you're looking for. So we know that the class, right, because that's the attribute on the element, class is equal to data field and title field. So we're going to say class should be equal to data field and title field. So instead of finding all the divs, it should find just the divs that have that class of data field and title field. So there should just be one. Let's give it a try. All right. It's also giving this error message. Let me run that again. So we're going to run again. And so it does return that one div that we're looking for. Oh, actually returns two divs. So we'd have to inspect that. But first, let's take care of this. There's an error message here where it says there is, it's basically saying, you're not telling me what type of parser to use to parse this document you're sending to me. So if you tell me how to parse it to begin with, then I won't complain about guessing because it's guessing that you're trying to parse HTML, but you could be trying to parse XML too. So it's complaining that you're not telling what type of document it is. So you can just pass this to it. Say, okay, this is HTML document. Use the HTML parser for it, and then it should stop complaining about that. Yeah. All right. So back to our mystery here. So we have two divs. So if we look at the HTML page again, it found this one, but then it said something about accession number too. And so if we come down here and find the accession number, we can see here that it is also, there's also basically they reuse the same classes even though it's not the title of class. They reuse data field and title field for the accession number field as well. Probably because it was easy and it's just basically the same font size, so they were like, we'll throw it in there. So that's a problem for us, right? Because like the first one is the title, and then the second one is the accession number. So what we could do is, knowing that fact, and that we could test for it. So we could say, let's start changing these variable names. So we'll call this title and accession number. And so we could test for that and say like, okay, if the length of this result is equal to 2, then we know that title is going to be the first one, and the accession number is going to be the second one. right? So like there's still always two hits in the first one, but we could say, you know, else if the length of it is only one, then we'd say, okay, well, we know for sure the title is going to be the first one. And then we'd say accession number is equal to none because we can find it, right? All right, so let's see if that works. So if we printed out this title, let's see if the title, and we'll print out the accession number. See how it looks. All right, so here's the title, and then here's the accession number. And so what it did here is it's still HTML, it's still an element, right? Those queries return HTML elements. They don't return text or the value of the HTML element. So what you would need to do is pull out the text of the element that you want to work with. And so that would work fine for the title, right? For the title one. So let's do that really quick and see how that looks. So we'll say it's going to be equal to the text of the title. And then, you know, let's add a final else statement here, and we'll say, so if it's not two length and it's not one length, then we'll say no title found. All right, so we'll know something funny is going on. All right, so we're pulling out the text now. So let's see how that looks when you run it. All right, so there's the title, and then the second one is the accession number. And so we can do that as well. We can pull out the title, or pull out the text just by doing that text on that result and look at it again. But we get this kind of like accession number prefix in there. So the problem is that there's more elements in the result than just the text, right? The title just had the H1 element and it had the title in there. But this has a nested span that has the accession number in it, and then it has another span that has the actual value in it. So knowing this, we could actually write a second query based off of the first one results to just look for that span. And so now at this point, accession number is stored in here. It's an accession number element, right? And then we could say, what's nice about Beautiful Soup is that every kind of query that you do and take a piece of it away, it still has all those built-in search abilities into it. So now you could say, in this little fragment of the accession number that I pulled out, which we know has nested spans in it, we could say, okay, now find the span in that thing that has the class of, and then we have to go back and see what the class was, but that has the class of default or detailed field value, right? So there's a label and then there's a value. And so it looks like a lot of them have that. There's like a label and then there's a value for nested stuff. So we don't really care about the label, we just care about the value. So we're not gonna pull out the label. So we're saying, okay, find, we're gonna overwrite itself and say find just the detail value, and then make yourself equal to that text value of that. So we're converting it from an HTML element structure to just the text, the string. So if we run this now, we should see that we have just text. Yep, so there's the title, and then there's the accession number pulled out into its own variable, separated, ready to go. All right, so the next thing we would do is go through each one of these and figure out an approach to pull out the data for the rest of the fields. So we'll do, for example, we'll do date, and we can do a creator here. So let's look at the creator. And so you can kind of break apart this based on how the HTML is structured, right? So this has a class called detailed people field, And then there is a detailed people span in there, and then that has a field value, and then it has inside of that is the name, and inside of that, or also inside of there is the nationality. So these two spans live underneath of this A link, and they have the name and the nationality. So if you wanted to, you could pull out those pieces separately, right? If you wanted to store the nationality and the name separately, because it might be bad to have them in the same field, because then what's the name versus what's the nationality? And they also have a URL to the person itself, which might be useful for later purposes, but you never know. So the thing that we'd be worried about here is like what happens if there's two creators involved in a work. So you could probably, it might be worth spending some time to try to find an object that has multiple creators. So actually this one doesn't even have any creators. Oh, it does. It just has Italian Florence as the creator. Yeah, so you could try to spend some time just to get the lay of the land to see if there are items that have multiple creators associated with them. And if they do, you'd have to see how the HTML is structured for them. But it might be difficult to find one. So, if you do write this code and it comes across that and it breaks, then you would know that you came across one with multiple creators. So let's go back to R1 and we'll just go on the assumption that we'll pull out the information with the multiple creators. And we can also notice from that previous kind of looking around that there's not always a nationality, right? So if you look at this Italian Florence, there's no nationality listed there. It's just one, just the name, the person. All right, so knowing that too, we have to make our code so it's aware that there could be a nationality sometimes and sometimes there isn't. All right, so let's write some code to do this. All right, so first thing we want to do is pull out the detailed field and people field, right? So that's this whole block of text here. So let's go to our code here, and we'll move on from the title, and we'll say, okay, let's do, we'll call this creator element is going to be equal to our soup.find. And so here you'd have to run into this problem of like, well, if there are multiple ones, you probably wouldn't want to find all, you probably want to find all of them versus finding just the first one. So right, the difference between finding all and find is just that the find returns the first one it finds and find all returns them all as a list. So you'd want to really think about this. There's probably going to be ones that have multiple creators, but you'd have to go back and figure out how that's going to be structured. So for right now, we're just going to pull the first one, the first creator, and go from there. So we're going to find a div that has the class of data field and people field. And so we could check this to make sure it exists, right? So it could have done the query and it didn't find it, maybe because there's no creator for this item listed. So let's just print out what the value of that creator element is. All right, so return this big div as the value of that. So what would happen if we said it didn't find it, right? So let's say we were looking for a class that had the letter ZZZ here. And so it's not going to find this. Let's see what it says. It is the value of it is going to be. All right, so this says its value is none. So this is a kind of a nice way to check this, right? So we could say, okay, if the creator element does not equal none, then do this stuff. Otherwise, print no creator found, right? So we kind of wrote like our own little fail-safe here where it's going to make sure it actually found what it's looking for before it goes in and assumes that like, okay, I'm going to look for this and this and this and this next. So it actually has to find that piece first before it starts proceeding to the next steps of stuff you want to pull out. All right, so we have that div then. If it's there, we have the div and it works. And so we know that the person's name is going to be stored in this A link. And the A link has the URL to the person page, like this landing page for the person, and then it has these two divs underneath of it, if it has two divs underneath of it that are the name and nationality. So what we could do is we know that there's always going to be a link here, so it's always going to link out to this person, so we could just find that a link and be done with that. So we'll say call this creator element a link is going to be creator element finds, right? And we're just going to find the first a link that is in there because we know there's only going to be one a link. So we can print this and see how it looks. And so return that a link. And so now we know that there's going to be possibly multiple spans in there that have the different parts of the name. It's going to have the name, it's going to have the nationality. We also want the URL, this piece here, to the person. We might want to save that for later. So we can access all those pieces pretty easily. And I'm going to make these variables up here so that we kind of know exactly what we have to use. So I'm going to set them all to none to begin with, and then if they get populated, they'll be filled in as the script goes. Otherwise, we'll come out at the other side with all these variables set to none if it wasn't able to find them. All right, and then we're going to have a creator, and we're going to have creator nationality, and we're going to have creator URL. Right. All right. So we know we have the A link here. So we have the URL, and in Beautiful Soup, to access one of the attributes of an element, you just treat it like a dictionary. So the link to the person's page URL is stored in the href attribute. So you just say bracket href, and you'll be referencing that attribute. So we'll say creator URL is equal to a link element bracket href. So store the URL there. And so now we know that there is going to be at least one span, maybe sometimes two spans that has the creator's name and then the nationality. So we'll create a new variable called creator data elements. And we're going to query our a link to say, okay, now find all of the spans that live here. And so now it's going to return, let's print out what it's going to return. Now it's going to return both those spans, right? So here's that first span that has the name, and then here's the second span that has the nationality. Well, actually, there's three spans here. The first one is the name. The second one is, there's like a nested span in here. And then there is a second span, which is the nationality. So yeah, let's look at this HTML and see if this makes sense again, just to be clear. All right, so we've found this piece here, right? And we said, okay, we got that A link, and now say it said find all the spans that live underneath this A link. So it found this span, and it found this span, but it also found this span that lives underneath of it. And so now we actually found three spans altogether. So you could do a couple things. So you could either check to see if this thing has a class of detail bold, and you know that's the name, or you could kind of go on the assumption that there would always be these three spans if there's a nationality, and then there'd be two spans if there isn't a nationality, because this one span is always probably going to be there. All right, so let's just do that based on the results here. We could say, okay, so we're not really interested in the first span, but if there is three spans, then we know that there's a name and a nationality. And if there's only two spans, then we know it's just the name. So we can write that into our code to check that. So we have data creator elements, so we can check how long it is. So we'll say if the length of the creator data elements is equal to 3, then we know that it does have the name and the nationality. Else, if the length of the creator element is only equal to 2, then we know it's just the name. And then we'll just have an else saying, uh-oh, something happened. All right, so if there's 3 of them, then we know the second one is a name and the third one is a nationality. So we could say, okay, creator is going to be equal, that's our, set it up here. We say creator is going to be equal elements, that's the 0, 1 position, dot text, and the creator nationality is going to be equal to 0, 1, 2, dot text. And then if there's only one, or if there's only 2 of them, then we know that that's just the name. So we're just going to have creator element equals dot text, 1 dot text, and no nationality. All right, so hopefully we should at the end of this get the creator and the creator nationality and the creator URL, all 3 of those. All right, so there's the creator and then there's the nationality. There's just kind of like a little space there. So what we could do is strip it out. So there's a method built into all strings called strip, and it just removes any extra white space at the beginning or end of it. So I'll just put those on here too. And it'll just strip out any extra space at the end here. So let's see how it looks. All right, there's a nationality and there's the creator and then there's creator URL. All right, so we got the creator's information pulled out. And so, you could take off the brakes, right? Release the brakes to see if this works across multiple entries, multiple objects before we get too far into doing it more elements, right? So I'm just going to comment out the break. And so it should start printing lots of creators and hopefully not error out, right? All right, so it's going through each one of these and we can see that it's pulling out lots of data. Sometimes there's none, sometimes there is nationality. Looks like sometimes there's life dates in the nationality thing too. But what's most important is that it's not breaking, right? It's at this point it's tested 137 objects and it hasn't failed yet. So that's not exhaustive, right? But at least it's better than just doing one and assuming it's going to work for all of them. So let's go back to our code. We'll put the brakes back on. And now we'll move through the next elements. So we won't do all the elements. We'll just try a couple more just to get a hang of it. And then you could do the rest. So the next one we may want to get is medium, right? And so medium is stored in detailed field, medium field. Here's the HTML. So medium is stored in these div, detailed field, and medium field, and then it has the medium tag and then the walnut wood. So this is kind of repetitive for the rest of the label field values. So we could kind of write one of these and then it'd be the same for the rest of them. So we're going to make a medium value up here. It's equal to none. And then we're going to say, okay, we're going to find all of our, make sure that's unindented. All right, so I kind of get messed up here. I'm started putting code inside of the creator element block. So we want to make sure we're clear of that. So we're going to say, okay, we're not looking for the creator anymore. We're looking for the medium, and that is stored in this field called data field and medium field. So let's change that to data field and medium field. And that's going to find the medium field, and if it returns it, then we want to make sure it's actually there. So we'll say if medium field does not equal none, then we know it was actually there and it worked. So then if that's true, then we know that the medium field is going to have a children spans. One's going to be the field value, and one's going to be the field label. So we know we want the span that has the detailed field value instead of the label. And so we'll just say, okay, well, creator, or sorry, medium is going to be equal to our medium element. And we're going to find the span that has the class which is equal to detailed field value, close parentheses. Gotta make sure we put a comma there. All right, so now medium is going to be actually equal to the result of that query, which would be a text string, right? It's going to be a span element, and we just double check, be very careful, and say like if medium does not equal none, then say medium equals medium.text. So if it actually worked and it found the span we're looking for, pull out the medium and then pull out its text. And we could even say, you know, just in case, we'll strip it if in case there's any extra white space around it. So let's print out medium and see if we should get a medium results. Yeah, there's walnut wood. And then of course, you know, take the break off and try it for a few other ones. So I remove the break and run it again, and we can see it's finding. So you really would want to spend some time with the data here and make sure that you are sure that like there's only ever one medium, because you know of course there could be multiple mediums. So if there are multiple mediums, how do you handle that? So you guys spend a lot of time with the data with the site to see what you are writing your queries for is actually what's going to show up and is actually what's there. So we could go through for each one of these and add the rest of these in if you wanted to, but they're pretty much the same as the one we just did. Here is something a little bit different. There's like a tag button here. So these are like category labels. And so there is a div here that holds all the eMuseum detail categories, detail field, collection field. So what you could do is make an assumption and say, okay, well, if there is a, if this field exists and then there's going to be li elements underneath of it, then we know that it has these tags. And I think I've seen for sure that there's been multiple tags for elements sometimes, like many tags. So what we could do is first we want to pull out this block, this div here. So we're going to do, we're going to add a new data piece here. So we're going to call this at the top of our script, we're going to say tags, and we're going to make that an empty list because we know for sure that there's usually multiple ones of these. And then down here, we could search for that thing we're looking for. We'll say tags div equals our soup dot find all, or find just one. There's only going to be one of these. It's a div, and it's going to be I have a class that's set to this. So it has like 3 classes. So if it found that, so say if div tags does not equal none. If we found that, then we know that there are some tags in there. And we know just from the structure of the HTML that we could say, okay, now find all the list elements that live in that div. And all those list elements are going to be populated with A elements that have the tag name in it. So we could say, okay, we'll say tag li elements equals tags div.find all, because there's going to be multiple, right? Sorry, we'll go back here. We'll start over. So we're going to say tag tag li elements is going to be equal to tag div.find all. and we're looking for li elements. And we don't need to specify anything else because we want all the li elements that are in there. And so now we could loop through each one of these for li in li elements, and we could print them out and see how they look. Oh, I didn't take the break off, so it's doing for all of them. But it looks like there's bronze, or here's li elements. So this one has a tag of being object on display, and it has a tag for sculpture. So there's two li elements there. This one has one for sculpture and one for on display and one for works in virtual tour library. So you would have to decide, do you care about the URL that are associated with these tags, or do you just care about the tags themselves? It really depends on your use case or your research question here. So I'm going to say I don't really care about the URL, just to make it a little easier. I just care about the text, right? So if I have the text, I can just say dot text. And so if I have that, then I can just append it to our tags. And tags is just up here defined as an empty list, right? So if that, it will loop through each one and append the text. And we could of course strip this too, just in case there's extra space around it. So at this point, we have all of these pieces of data populated or set to none if they aren't there. So I'm going to go through here and clean up our debug code here. I'm going to delete a lot of the print statements that we don't need. All right, and so what we would do at this point is keep going, right, for the rest of the fields. There's many other fields that you probably want to pull out, but we kind of covered all of the edge cases, and we covered the main use case of, or the main example of finding a field label value pair. So the last thing we want to do is do something with this data, right? So we've been putting it to the screen, but we probably want to aggregate it somehow, right? So we would make some place to put all the items. So we have all items, and we'll make that actually an empty list. And so what we could do is make a new list item or something like that, and we're going to make it to a list or a dictionary. And we're going to make a dictionary that has all these key value pairs. So let's copy and paste what we had up here. So these are all the things that we had available to us. So we have title, so we'll make that to title. And we have accession number, make that accession number. And we'll just do this for all the elements or all these pieces of data that we've created. So we're basically creating a new dictionary of just this stuff. So instead of us having all these loose variables kind of all by themselves, all over the place, we're gonna kind of put them all into one dictionary for each item. So each item will be represented by one dictionary, and there'll be many of them. We probably want to save the URL that we use to access this item. So that's stored in this URL here. And so now we have this list item, and we can do something with it, like put it into our all items. So it's going to be appending this list item with all these fields populated to for each item, for each page it goes through and adds it to our big empty list of all items. And so the last thing we want to do is at the very end is do something with this data, right? So right now we're printing to the screen, we probably want to put it to a file. So if we want to do something with the file, we want to save it as JSON, we need to import our JSON library. And then we can easily say with open frick data.json as write mode, and as this, we'll say frick file, and we'll say json.dump this data piece, the all items, dump it to frick file, and set the indentation to 2. And so you put this here at the end after everything, and it would do the last thing, right, and write everything out. I'm going to actually indent it and put it underneath of the for loop, the big for loop for the item loop, because I want to write it out for each iteration just to see if it's working. You don't really need to write it out each time. It's kind of a waste, but it's not that big of a deal. All right, so let's see if we get any errors. All right, so as that's running, I'm going to go back to my editor and pull in the file that's being built here. All right, so this looks pretty good, right? You want to go through and check out if these things are working as expected, right? So there's multiple tags are working, medium, all the rest of the stuff. So you want to check, make sure everything is coming in as you expected it to. And then again, you'd really have to spend some time with this data and find out these edge cases where there could be multiple mediums, could be multiple creators, even multiple titles. All of these things are possible with this metadata. And you're very limited to how it's presented in the web interface. So you kind of have to do some exploring on how it's working. All right, so you just leave this running, right? And it's just going to go through all the items and pull out the data. Let's see where it got to so far. It's up into the 200s, 300s. All right, so you let this run, right, and it would eventually pull out the data. One edge case, right, could be, or a situation could be that you start getting blocked by the website, right? It might have a very aggressive kind of rate limiting system, right, where it might say like, hey, this person's like requesting hundreds of pages over the course of a few minutes, and so it might like start blocking you for temporarily or banning you for a certain amount of time. So if you find that that's happening to you, you can actually add in a little delay to the script. And so there's a module called time. So you could import time, and then you could just say, you know what, okay, the first thing I want to do in my loop is just wait a second. So you could say time.sleep and then 1. And so that will actually pause the script for 1 second before it goes on to the rest of this. It actually hits this line and just stops for 1 second, or it would hit this line and stop for 10 seconds. So if you find yourself trying to scrape a site and it's like you're running into like network connectivity problems and it's like blocking you or banning you or something like that, you want to slow down your script somehow. This is a very easy way of slowing down the script. So now it's for each loop, it's going to sleep for 2 seconds before going on to the next one. So let's see if we can notice the difference. Right? So 1,000, 2, 1,000 goes on to the next one, right? So if you're running into these problems where you are getting blocked or whatever, you can always slow down your script to make it a little bit more polite while it's interacting with the rest of the internet. But yeah, so this is a good start to get looking at how you first kind of identify a strategy for pulling out elements and then going through the steps of like using Beautiful Soup to query for specific things and making these like internal logics in your mind about, okay, well, there's like 2 divs here, so the third one's going to be nationality, et cetera, right? So it's a lot of trial and error, but eventually you can get to a point where you're building a really cool data set. So for the next one, we're going to look at the Milwaukee Museum of Art, and it's a slightly different problem. Milwaukee Museum of Art site. And with this one, we decided, okay, it makes sense that you could just use the search result page to go through and pull out all the artworks. And say we're just mostly interested in like things like titles and authors or creators and dates and stuff like that. That data seems pretty much available to us in the search result page itself without having to go into the individual pages. So maybe our first approach, things like dimensions are not in the search result page though. So maybe our first pass would be just pulling out that data, and then if we have the URL to get more data, we could go back later and get more data. So the general idea would be like, okay, start with page one and go all the way through 197. It's always good to check to see if the actual web page would actually do that for you. And it looks like it is. Great. And so we can see the URL is structured up at the top here. It's a little small, but it says 9,800. So basically, it's like that it's passing the offset of where to start on the page. Because if you go to the first page, that offset is 0. And then the second page, the offset is 50. So you'd have to increase that number by 50 every time you loop until you got to 8,000 or 9,800, right? And then you'd be on the last page. So they don't really work by pages, they work by pagination, and there's this 50 items per page, and then so you're starting at item number 9,800 and go to 9,850, right? All right, so we'll start off with this Milwaukee Museum of Art. And you'd want to check around. I couldn't find any APIs. I couldn't find any data sets available for it. So if I wanted to do some kind of project around their collection, short of actually interacting with them and like asking them for information, this is a public site, so I could just scrape it and just test it, do some um, quick project around my whatever I'm trying to research question I'm trying to answer here. All right, so we know that we have a base URL here that we're going to be using, and then we have to parse the data to pull out this information. So the first step is let's write a script to do this. So we're going to start off with a empty script here, and I'm going to save it. I'm going to put it in my desktop. Put it on my desktop. And I'll call it. I'm going to make a new folder called Web Scrape. All right, I'm gonna call this one, we're scraping the Milwaukee Museum of Art, so we're gonna call it MAM scrape. .py. All right, so as I mentioned before, the first things that we wanna do is make sure we install those libraries from pip. You want to install Python and Beautiful Soup. And then the second thing that we're going to do is make sure that we include those libraries in our script, right? So we want to basically import the two things we're going to be using, which is going to be import requests, right? Because requests is the script that allows us to talk to websites and web pages. And then we're going to also import Beautiful Soup. And so the import for Beautiful Soup is a little bit different because it has multiple things in the library. So we're going to say from BS4, that's the name of the library, import Beautiful Soup. All right, so we have our two things imported and ready to go. So the main kind of workflow is we're going to request something with requests, and then we're going to process it with the Beautiful Soup, and then we're going to repeat the process and look for different stuff. So the first thing we need to do is make this request to the website. So we know that we're going to get started with the Milwaukee Museum of Art site, and our current approach is to use this URL and just change the start number every time we want to increase the page by 50. So you might want to play around with these other parameters, like what happens if we get rid of this type equals quick search. Let's put that back in the browser and see what happens. Not much changed. And then the search item is empty, so it's returning all. All right, so we have our base URL here, and then we know that we're going to be changing this number every time to something plus 50. So starting off, let's see if we can write a script that just generates this URL pattern for us for all 50 or all pages that we want to iterate through, like 197 pages. We know that there is 9,800 total, right? And so we want to add 50 to it for each time. And so in this case, we could use a while loop. We haven't really used while loops before for very much. but we could use it for this because it actually is a good fit. So we could have a item counter equals 0, right? That's the start. And then we could say while item counter is less than or equal to 9,850 or 9,800. That's the last page you can get to. While it's equal to that, well, it is less than or equal to that, then do the stuff in the code here. Do this stuff. So this is going to keep looping, and the only thing is that the item counter has to increase, otherwise it'd be stuck in an infinite loop, right? If item counter is never bigger than 9,800, then it will never stop looping. So we want to make sure always the last thing that we want to do is increase item counter. So we'll increase it by 50. All right, so now we have this thing that should loop not 197 times and build this URL each time. So let's make the URL, and we know the URL is this thing that we copied from the site. And so what we can do is we can make this into a template, an F string, and just replace this 50 with whatever it is going to be for that iteration, that item counter. So the first time it will be 0, and then it will be 50, then 100, etc. And let's just print out this URL to make sure we're doing it right. So let's go try to run this. It's on my desktop. It's in web scrape. I'm going to Python 3 mam scrape. Yeah, so we just want to make sure that these URLs are the right URLs. It starts at the right place, 0, and goes all the way up to 9,800. All right, so let's do the next part where we're actually going to be requesting this URL and then doing something with it. So what I'm going to do is add a break command to the bottom of this, and that break command basically breaks the loop cycle because we're just going to be playing around with the first page, and we don't want it to keep going yet because we're not done with that part yet, right? We haven't even started figuring out how to scrape the first page, let alone all 197 of them. So we don't want it to keep going and have to stop it. We just want to do the first one, and then we'll go from there. All right, but this still needs to be at the bottom. All right, so we have the URL. So the first thing is we're going to use requests to get the page, right? So we're going to say r equals request.get and then the URL. And now we could do a check like check the status code to make sure it's 200, do all those sorts of things there. But we know that the HTML is going to be stored in the r.txt, right? That's the text of the request. So if we try running this and we printed out the r.text, here is the HTML. And so the next step would be to, once it's in we have the actual HTML, which is in r.text, we can send it into Beautiful Soup and it will process it. So we'll say soup equals Beautiful Soup, and then you send in the text that you want it to parse. And then let's print out Beautiful Soup, or print out soup and see what it looks like. And it prints out the HTML parse. All right, so now we've gotten to the point where we parse the HTML into the Beautiful Soup program module, and it's processed it and it stores it inside. And so what's the powerful thing about Beautiful Soup is that now you can use it to query the HTML. And so by querying it, I mean you can look for certain characteristics of the HTML page and then filter it based on exactly what you're looking for. So, for example, if you wanted to find, you wanted to find all the images on the page, you could look for all the image tags and query Beautiful Soup to look for that specific tag. If you want to look for a specific element that has a specific class associated with it, you could find that. So what we're going to do is we really need to figure out or explore the structure of the page to understand how we want to know what to even search for. So if we go back to the sites and we inspect this stuff, we can say like, okay, we're interested in this stuff here, right? The items being returned. So we can inspect this by right clicking and going to inspect. And that will open developers tools in our browser, and it will show us the hierarchy of the web page and its HTML elements. So now is a good point where it's like if you have a little bit of HTML knowledge, it's useful, but it's not necessarily needed for what we're going to be doing. But you really are trying to kind of figure out the best approach for getting to the piece of data, piece of HTML that you are most specifically interested in. So, for example, if we look here, we can see as I hover over this that each individual object that we're interested in is stored in a div here. So each div has all the metadata in it for each object. And so you kind of have to think about like, okay, well, how can we get to each one of these? What would that query look like? And so you can kind of think about this in natural language, like, okay, beautiful soup, find every div that has this class object work and return that to me, and I'll do something with that div. So for the first way that we're going to filter down all of this HTML into just the pieces that we want is to say, okay, filter it all on divs, and then not only divs, but divs that have the specific class, right? If you know nothing about HTML, class is just basically a way of giving it a style to it. You can add a style to it so it appears in a certain way. It assigns all these rules for display rules, things like color, font, all that stuff, layout, etc. So we can try doing that by in our script saying, okay, beautiful soup, I want you to find something specific. And so I can say, okay, I'm going to store the results of this in a new variable called object divs. I'm going to say, okay, beautiful soup, this is the variable that was the result of parsing the data. So we'll say soup find all, and what do we want it to find? We want it to find all the divs, so the div elements. So let's just print this and see what it does. All right. So if you look in here, it looks very similar to what we saw before, but if you look closely, you'll see that there is a square bracket up here, right? So it's not just HTML, it's not just a string, it's returning it as a list of div elements. So all the div elements have been broken up into its own item in the list of things. So here's another div, here's the end of that div. So this is all one item in the list of things. So this is great, right? But it's not necessarily getting us to what we want to do, right? So what we actually want is the divs, but you want to get divs that actually have a specific class name or a specific attribute, right? Because the classes are stored in the attribute class. So what we can do is pass a second parameter to this find all, and we can pass a second parameter and pass, So what we can do is pass a second parameter to this find all, and we can pass it to say what are some more defining characteristics of these divs that we want to find. And so we can pass this as a dictionary, a key value object here. So the thing we want to look for is class, and the value that the class should be is, let's go back and look, is actually called object work, right? So we're saying find all the divs that have the class object work. And right, this could be a different attribute in the HTML, but in class is just the one that we're looking for. So let's try this instead and print this and see the results here. All right, similar still, but if you see here, there is a curly bracket and another curly bracket or square bracket, so we know that these divs are being broken up. And so if this is a list, then we know we can do what we do with lists all the time, is write a for loop and loop through them. So instead of printing them all at once, we could say for a object div in object divs, print a object div. So now they should be on like each line by themselves, right? So let's try running that again. All right, so now we can see each div has been broken up into its own line. And we would expect to see that there would be 50 of these, right? There should be 50 of these. And so there's definitely not 50 here. So you would have to say, okay, well, what is the problem here? If we inspected the page some more and looked at the page, we can see that not only do the divs have to have object work in them, but it looks like there's also either object work even and odd, right? Kind of like a second class in there. So you can always look at the page source and look for these things specifically, right? So it looks like there's some items in here that just have object work as a class, and then there's some that have object work and maybe even and odd. Huh. So I'm not seeing that either. All right, so we want to make sure that the key thing is we want to make sure that we're getting all of the items that we're expecting to get, right? And so we could test this again just to make sure by checking to see if there's 50 things in this list. So the last thing I'm going to do is print out the length of this list of objectives and run it again. All right, so there's only 10 things in this page here, which maybe makes sense. Let's see this site again. So I'm changing the, so I'm back on the site, I'm changing the result per page from 30, 50 to 30, etc. And somehow somehow we'd have to figure out how is it passing this information to the server, right? Because we're saying what number to start on, but we're not telling it through this URL how many items per row to return. So it's kind of suspicious in that it knows to return 50 or 20 or whatever, right? So let's try to change this again back to 50 and look at the network tab on our inspecting developer tools here. And so here's the main page to search. And you can go through here and see what properties you're passing to it. And so it looks like it's passing this limit here in addition to the URL. So it's like there's different types of ways of interacting with web pages. There's a way you can get something from the web page, which we use with requests. You can also post. And so this is like posting a URL to the web page somehow, which is causing us, when you change this number here, it posts it to the web page, and it returns the number of, increases the number per row. So I'm going to clear this again and click next and see what it does. So if I had to guess, I would have to say like it's doing some sort of like cookie storage thing or something like that. Like when I change the settings on the web page, it sets it to 50 for the browser, this specific web page in this specific browser. And then it knows that when it's talking to the server, it says like, oh yeah, I remember this browser. I'm going to send them 50 because it's set its default to 50. But when we think about our Python script, it doesn't have this interface. It doesn't have this browser interface. It doesn't have these cookies, right? It's not storing session information. So the server sees this Python script and it says, you don't have a limit set, so I'm going to send you 10 because that's the default. So we can mess around a long time and try to figure out how to get set that to a certain page number, or we could just stick with 10 and then adjust our script accordingly, right? So we'll do 10, and then we need to go to 9,804 pages. And so this, we just need to change our scripts so that we're not asking by 50 for 50 each time because it's not going to be 50. We're just going to be asking by 10, right? All right, so it's a little confusing, but basically there's some functionality in the site that enables larger result sets in the browser that we can't replicate in our Python script. So we're going to have to go back to having it just 10 per request. All right, so now though, if we run this for the first one as we did before, it will make more sense because there's 10 things and there's actually 10 results. We can actually see, we can pick the last one here and see that it is a Rockefeller Center with Colgate Church of St. Nicholas in the foreground. So we go to our homepage, our page again, and make sure that's like the first thing on the page, or the last item on the page. Yeah, Rockefeller Center with Colgate Church, St. Nicholas foreground. All right, so it's working as expected, right? It's returning 10 things for the first page, and we can see that they're there. All right, so now we have the pieces of the search results, right? We have each one of these items we've managed to pull out and have access to it. So we have access to this block of HTML, to this block of HTML, etc. And so the next thing is we want to pull out the structured data around each one of the items, right? So we'd have to kind of take a survey for what possible fields are there, but when you inspect it, right? So I'm inspecting this chair metadata for this chair object. And we can see that here is that work object that holds everything. And then inside of that, there is a credit UL element that has the creator, and it has the maybe more creator information. And then it has this LI element with the name of the object and then the date of the object. So you'd have to inspect some other ones, right? So here's another one that has many more creators, or at least much more information. And so it has, here's a credit URL again, and it has some data about the creators. And then it has this title, and it has the date. Let's look at another one. So it has this credit UL here. It has the creator, then it has the LI with the date and the title. So the whole key about thinking about how to scrape stuff is looking for patterns in the HTML elements, and then thinking about how you could translate those patterns into kind of like an approach, or like a pattern that you could apply to your code to look for it. So if I had to come up with a pattern for these things, and you notice it's not making it very easy for us, right? It's just a bunch of list elements basically listed together, and there's no other classes saying like, oh, this is the title and this is the creator and then this is the date, right? That's not how it works for this page. They didn't add those special pieces of distinction to the elements. They're all basically just LI elements. So it's not very like semantically coded. It's just very kind of like all out there, right? So if I had to create a kind of basically a pattern, I would say, okay, so all the LI elements are basically something to do with either contributors or creators to the work. So something like a photograph, there's only one um, creator, but something like a chair, there's a creator and then there's like a manufacturer information too. So you would say, okay, so there's creator information for all the list elements in this credit UL, and then it seems like the very last list element has um, the name of the work and then the dates there. Some other information in here is also the link to the thumbnail, which could be cool, right? If you wanted to do something with the image later. All right, so we would need to kind of codify these into approaches to scraping. But it seems like that's kind of like a true statement, right? So there is a bunch of lists, usually a bunch of list elements, and then there is a last li element, which is the title and the date inside of the A link. All right, so it's a lot of like trying to dissect these the folks how they put the page together and then figuring out how to kind of like reverse engineer it for your purposes. So let's start with something easy. Let's say we want to store the image name, the URL to the image, not the image itself, but just the address to the image. We know that that's going to be in there's only one image link in the entire div, right? That has the link to the image itself. So what we could do is what's really nice about Beautiful Soup is that if we go back to our code, in Beautiful Soup, anytime you subdivide a Beautiful Soup object, like when you do this find and it returns results, each one of those things that returns is also a Beautiful Soup object. So that means it also has the things built into it like find and find all. And so what we could do is let's let's make a new variable called thumbnail. And this is going to be we're going to reuse the div that we're looping through, right? This is the object work that we're looping through for each of the 10. We're going to say find. We're not going to find all because we just want to find the first only one. And find image. And then print out that image result. So let's try running this and seeing what it turns up. All right. So the first thing, this has been happening this whole time, but basically it's saying it's the Beautiful Soup library is saying I'm trying to guess what kind of thing you're trying to parse. I think it's HTML, but you're not telling me specifically what it is. If you say HTML parser in your Beautiful Soup constructor, then you'll stop getting this warning message. So I'm just going to do that. What it's saying put this into your Beautiful Soup constructor to stop from getting this message. So let's throw that in there really quick. So we're just going to say use the HTML parser. Because HTML is very XML-like, so there's other types of things that Beautiful Soup can parse. So let's try it again and see how it comes back. All right, so it returned 10 things, right? 10 image elements it returned back. And each one of these has these class and it has the source. So what we could do is we're interested in this piece of data, right? The stuff in the source, which is a link to the URL to the image. So we could try printing out just that by saying, I think you could say source, I believe. Let's try it. I'm not sure. Yes. So like treating it like it's a dictionary, you can get access to the attributes of that element by just saying parentheses or brackets src for the source. Um, and so we can see that there is usually going to be an image URL, or there's going to be not available GIF, right? So let's add our logic into that here. So we can make a new variable called image URL. We'll set it equal to none to start with, right? So the default thing will be none. And so we'll say if thumbnail, the source element thumbnail does not equal this not found, not available GIF image, then we know it is available. So we'll set it equal to that. And you notice that these things are going to be their relative URLs, right? So there's not a full, you don't see an HTTP here. So what we can do is go back to the web page and open this image in a new tab. And then basically it's going to open image in new tab. And it will return the image with the full URL for us. And so the full URL has collection.mam.org and then slash the rest of it. So what we can do is modify the script so that it adds that little bit in the front of it. And then let's print out the thumbnail URL. Right, so for the ones that did not have a valid image, like it's just not found image or it wasn't digitized yet, then it has none, and then for the rest of them, it has the full URL to the asset ID. So if we put one of those into a browser, it would pull up the image. All right, so we got the URL for the image. That's the first step, and so our second goal was to pull out this next piece of information. And so the problem was that we saw that the first line, so line 0 or lines 1 through X are the creator or contributor, and then the last LI element have these title and date stuff. So what we can do is we can say, like, okay, let's find the UL element first. So let's go to our code, and we'll say, okay, we'll say ULs equal objective dot find and then UL. And we can do this because there's only one UL in the entire div, so we just need to find the first one. Call it UL. And so then we know that we have the UL, and then each one of those has children, right? So let's print those out. And so you can say UL.children. And so it's not showing us, but it's saying it's a iterator, so we can list, it's a list, so we can loop through it. And so what you could do is you could actually force it to display it as a list, or you can loop through it. So let's just loop through it. So we'll say for, we know they're LI elements because we saw it in print LI. All right, so now we can see that it is pulling out the LI elements, right? So that's one way of doing it. The other way of doing it, as I mentioned before, is that we could force it into being a list to begin with. So we could say something like LIs equal UL children and just say make this a list. And we've done this before with like strings and numbers, forcing it to be something specific, but we can force it to go from this iterator thing, looping through thing, to just be a normal list. And so then we can print out that LISs. And let's just add a little line at the bottom of the screen just to separate the the individuals. All right, so let's run it again and see how it looks. All right, so now it's forced the LIs into being a list of LIs, and you can see that, for the first one here we have, or this example one, we have the first LI is a creator, and then the second LI has the title information, and then there's the date. And then similar for the ones that are more complicated, like this one where there's a LI that has a bunch of LIs. The first one, the first few of them are creators, contributor information, and then the last one is details, right? So knowing this, we could actually split up divvy them up into like creators or contributors, and then also into title and date information, because we know the last one's always the date. So we could say, okay, so we could say, let's try to test this out here. So let's say, okay, this should be all creators. And we're going to say we want that to go from 0 through -2, maybe. -1 is the last one. Let's see what this says. Give it a shot. All creators. So there's the first, yeah. So for the example, that first one that had all those creators, contributors, goes through there. There's Bernice Abbott. And so that's just the creators, right? And then we could say, okay, let's cut up that list so even more. So then we're just going to have print out the title, date, info. And then we're going to print out LIS, and that's going to go through just the last one in the list. Sorry, so we have all the creators, which is going to be a range of them, and then we have the title, date, info, which is always going to be the last one, which is going to be a list of stuff. Or just one LI with no list, just the title and stuff like that. All right, so we can proceed further with this to get this out of, because right now there's still HTML elements. They're not string yet. They're not text. We can't do anything with them yet. So the first step is to make a place to put these guys. So we'll say creators will be an empty string. Then we're going to store the title. It's going to be something. And then the date will be something. And so we need to pull these out by doing a looping through them, right? So we could say for a creator li in this range of stuff, for each one of these will be one of those li elements, right? Each one of these will be a li with Bernice Abbott, whatever. So we basically just want the text inside of there. And so we could say, okay, creators, that's our empty list here. Append, right? That's how you add something new to a list. And we'll say this.text. And so instead of printing out this range of the elements, we'll print out the range of, or we'll print out the list of text. All right, so now there's Bernice. Let's go to the first one. Here's all of these folks involved in that first one. There's a chair somewhere here. There's manufactured by Otto. Here's the creator tag. And so we've gone from having these being li HTML elements to just being strings in our new creators list. And of course, this is not very structured, right? Because there's like nationalities and there's dates, life dates in here, but you could maybe use some regular expressions to clean that up too. You might run into some problems for like stuff like this, where this is obviously, there's no life dates, it's not a person. So you'd have to work on that to figure out how you'd parse those. But we successfully separated the creators or contributors from the rest of the data. And so the last thing we want to do is pull out this date and title information, right? And so let's go back to here, and we want to pull out that information, which is in the very last LI element. And so what we can do is print out, we can purchase a couple ways. We can treat it like a soup object and try to find the piece of data in there, or we could just treat it as the same way as say, like, just show me all your children and I'll pull out the pieces what we want. I think for the title, we know that it's always going to be an A link. It's always going to be in the A link here. The title is going to be the text of the A link, and then we probably want to keep the URL to the A link too, so we can come back later if we wanted to and get more data about it. So we'll treat this as a soup object. So we'll say title equals LIS, that's the last LIS element, and we'll say find, and we want to find the A link, and then we'll say title dot. So now this is the A link, so this is the href, and we can say title equals title dot text. So that's the content inside of there. And so if we say print title is equal to title, let's see what happens. All right. Looks pretty good. So we pulled out this piece of data, even though it's nested inside of the italic element, this I tag. We pulled out the whole thing. And the only other thing we want to get is this URL for it. So we'll pull that out as well. So we'll make a new empty URL up here is none. So then we'll say, okay, and the URL should equal the title, and it's a href element attribute. All right, so we can clean this up a little bit. We're kind of like overwriting variables in kind of weird way. So we'll say, we'll call this title li. No, this is a link. So we'll call this title a link. So now we're not kind of overwriting stuff. The result of the search was stored here, and then we're pulling out the text, and then we're pulling out the URL and overwriting these up here that we have up here. All right, so now we have the URL. We could double check that by testing it. All right, there's the URL. It seems to be working. We could create it. We could make it go from a relative URL to absolute URL by adding in the domain and the stuff before the relativeness. So we could say like this. So I was gonna, sorry, we can add in here's the relative part of the URL, and we can just add in this hard coded here, so it'll create a full URL if we want to use that later. All right, so now the last thing is the dates of the work. And so if we think back to the state title info, we know that it also has children, right? So let's take a look at the children, and we're going to force that to be a list too, just to see what it looks like. All right, so here is that list of children for the last thing in the date title LI element. And you notice here it has two children. It has the title, and then the last child is the date. And then title and date. And then this one has title and date, but it has many dates associated with it. It has like date range and then design date. But we know that the first character is always a comma, so we can probably get rid of that. But we know that it's always going to be the last thing in that list is the date, or the position 0 or position 1. So we could be safe and say last thing, because then if something else comes in there somehow, then we won't get burned by it being not the last thing. So we'll make a new element here called, our new variable called title and date children. And we'll make it equal to that thing we just been printing out. And so then we could say, okay, date is equal to the last thing in that list. And then we could print out our dates. All right, so let's try to run that and see if it works. There's date. Oh, and we have this comma space. So we know that the first two characters are going to be not good. We don't care about them. So we could get rid of them by saying, and then date equals dates. Start off with the 0, 1, start off with the 1, and go through the length of the date string. So start off at 1 position and go to the end. $1936, looks like there's a little space there still. So we'll say start off at 2 and go to the end. All right, so now let's get rid of all these print statements. And let's just print out all the data together. So we have creators, we have the title, we have the date, and we have the URL to the object itself. And we have image URL. So let's run that and see it. Yeah, I think that looks good. So what we can do is kind of take off our break limiter here that we've had set from the beginning and kind of just let it go for all of them and just see if we run into any errors in the first couple pages, because now it should be doing this for each page as it goes. And so something that we could run into perhaps is maybe a certain one of these objects does not have a date or does not have a piece of information the same structured, and it's in such a way that it actually breaks the script like this, right? So it broke it when it tried to build this date length thing. And so what we can always do is we know it's breaking on the dates. So we could always print the date before it could potentially break. We know that it breaks here. So let's print the date before it gets to that point. And we'll comment out everything else. So the last thing we'll see is the date, and then it will break again. So it might take a couple of seconds here. All right, so it's breaking at a very specific point here. It's on the 9th one. And so if we inspect it, I think we can see that the difference is, so if we look at the previous one, this last LI element, if we look at the previous one, the last li element has a title, right? And the dates. But the title is wrapped in this I tag, this italics tag. And then if we look at the one that's breaking, we can see that there's the last li element and there's no I tag at all. So it's a different HTML structure. So it's not finding what we think it's supposed to be finding. So if we go back to the web page, let's take a look. And if you look here at here's the div for object. It goes through this one. So let's put this in our text editor just to look at it. So we have a div, there's the a link for the image. So here's the image. Then we have the unordered list. There's the first li, so it's the creator. Then we have the second li, which is the title and date. And we can see here that it has, this is the piece that's choking on. And we can see very clearly that it closes I element, but it never opens it. So it looks like it's really malformed HTML that's throwing it. So it's kind of like when it gets to this point, it's not able to parse this li element properly because it's like not valid HTML. The I element is closing, but it's not opening anywhere. So it kind of doesn't really come out right. So this actually kind of throws a pretty big kind of wrench into some of our plans. So you have to really kind of make sure that what you're doing is, any use case that you can run into is accommodated for. So in this case, there's some weirdly formatted HTML, and it's just not, it's breaking it. So I think this part still works, right? So we're still able to get that last piece. It's just, it doesn't look right to the beautiful soup engine when we look at it here. This is what it looks like. It's turning it into basically an empty A link, and there's no data for that. So it seems like we got to page 110 and then we have this one problem. So what I would say is, you could spend a lot of time fixing this, or you could make the code kind of just kind of avoid this problem, right? So let's take out all these print statements. We know that the problem happens here. So we could add a try block here. And when it gets this exception and it tries to do this and it breaks, we could just say continue. So it will just jump to the next one and not crash, which we don't want it to do. And so you could probably like maybe even, you could mark this one, before it continues, you could say, you could just print out this thing like problem with, and then put the URL. So that you'd have to go back into your data and fix this one or add this one in for yourself manually. So yeah, there's a few ways of kind of sidestepping that problem. For right now, we're just say like, let's skip over those really poorly formatted ones. All right. So we probably want to run this a few more times to test it, make sure it's working for the majority of these items. There's not something that breaks it. But once you get, we're on page 320, you probably are in a good space to say it's working pretty well. So I'm going to cancel it. And so the next thing you want to do is like save this data out somewhere, right? And so let's make a new empty list here called all items and make it empty. And what we could do is add in each one of these items as a dictionary to this empty list. So we have this empty list here. So we're going to have the image URL is going to be equal to image URL. We'll have creators, creators. We'll have title, title, date, date, and URL, URL. So we're adding into our empty list a dictionary for each one of these items. Comment this stuff out. And the last thing that we could do is write this out to a JSON file. So we'd want to import our JSON. And we'd probably want to put this at the end, right? Outside of the indentation. So it's the last thing down here. It's the last thing that happens when it's finished. But for us, outside of the while loop, I'm saying. But for us, let's just put it inside the while loop so we could test it. We'll say with open data, mam data.json as write, as out file, we'll say json.dump all items to out file, indent 2 spaces. So if we ran this, we'd see the URLs moving up, right? As it goes through each one. And it looks like there's quite a number of them that had problems with that. So yeah, you'd have to go back and either write a better kind of approach to these individual ones that have problems, or just go to this individual item and add that data in manually. But if we looked at the data file it's producing, you can see it's generating this dictionary for each of the items that it's scraping. Oh, but you can see, oh, image null. Image is sometimes null because it doesn't exist, right? So you could let this run, and it would just need to go up to the end of the pages, and then you'd have your complete data set scraped for this individual website. All right, so those were 2 examples of different approaches to web scraping, right? So basically it's the same idea for each, but the way that we accessed HTML was different for between the 2. The first page was just basically increasing the ID number for an object and just trying to like bulk, mass hit every single page that could exist. And then for the Milwaukee Museum, we had a little different approach where we were like looking at an index page and using that to go off of what actually was there. So I hope this is useful in showing that basically the first step to doing any sort of web scraping is figuring out how the web page works and understanding the content of it and how to navigate through that content. But I feel like these 2 approaches would be pretty common approaches for any sort of web scraping. This you can, of course, web scrape other sites that are not necessarily cultural heritage things. Anything that has HTML behind it would be, open to being scraped. And it's just a matter of trial and error, like I said before, just figuring out things and slowly getting into it. So thanks for watching, and I'll talk to you later. Bye.